Hi, I'm Nuria and I'm going to present my project. So I decided to make my project about the Hooke law. Hooke's law, or the law of elasticity, was discovered by the English scientist Robert Hooke in 1660, which states that for relativity, small deformations of an object, the displacement or size of the deformation is directly proportional to the deforming force of law. The formula of this law is F is equal to minus Kx. I carry out this project in order to test Hooke's law and check the elasticity of the spring when placing heavy objects on it. So here's a little theoretical framework. Says that a spring is an object that can be deformed by a force and then return to its original shape after the force is removed. Mass, a body of coherent matter, usually or indefinite shape and often of considerable size. Dependent variable is the variable being tested and measured in a scientific experiment. Independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable. The control variable, anything that is held constant or limited in a research study. It's a variable that is not of interest to the study's aims, but is controlled because it could influence the outcomes. So my variables and experiment, the variables are, the independent variable is the mass of the object, the dependent variable is the spring contraction, and the control variable is the elasticity constant. The experiment consists of placing different objects with different masses on a spring to see how much the spring contracts. I think if it's more mass the object has, the more the spring contracts. So if the object is too heavy, the spring will contract more. The materials I use are a spring, a flexometer to measure the length of the spring. For objects, I decide to select a liquid soap, a paint can, and a 1.3 kilograms exercise weight. And for measure the mass of these three objects, I use a weighing machine. So this is my experiment. I first measure the length of the spring itself, so when it's normal. Then I put the three objects on the spring and I measure the length of the spring. These are my results. The spring is about 13 centimeters. And the masses of the three objects are, for the paint can, 5 kilograms, for the liquid soap, 7 kilograms, and for the exercise weights are 1.3 kilograms. And about centimeters of the contract spring. When I put the object on the spring, the length of the spring with the paint pen is 10 centimeters. With the liquid soap, it's 9 centimeters, and with the exercise weight is 12 centimeters. And when I measure the force and the contractions in meters, first for the force, I multiply the mass for 9.8 for the gravity, like is in this formula. And for the contractions, I first do the initial length minus the final length to have these results, but I put in meters, not in centimeters. And now, this is my graphic. And I got an equation. This is my equation for the J's, for the Y's, sorry. And this is for the X's. And this is representing the formula of Hooke law, the F of force. And this is my equation. So I substitute the X for 0.01, 0.03, 0.04 in the x, and I got the exercise weight. The force is 14.5. The in the can is 47.23 or 83, sorry. And for the liquid soap is 64.5. So in conclusion, we can see that if the object is too heavy or it has more mass, the spring will contract more. Like you can see here, this is the most heavy object. So the spring contract a lot. This is the second more heavy, and this is the last more heavy, the least last. And if, o sea, using the formula F, the formula of the Hooke law, we can see that the spring has more force in the one which has more mass. For example, here, the liquid soap that is the most heavy, the force is 64.5. So one implication is that the spring did not hold very well the objects, and it was a little bit difficult to me to take the pictures and measure the distance of the spring or the length of the spring, because of the spring was not really or pretty solid to 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 hold the heavy objects. And one of limitation was doing the equation, because what was very difficult after doing the graphic. So as you can see, the graphic is in a line. So that say that it's okay. The problem is right for the experiment. And for another project, I will get a different spring, more solid. So the objects could hold better and more use. And I will do more objects to measure to have more information about the contraction of the spring. This is little references when I get the theoretical framework, and that's it. Thank you very much.